Calculator instructions here on how you can bring up the calculator settings that you need. And what you're going to find is this is exactly what we were doing before with the formula. It's just an easier way to do it, to put the information into your calculator. So you've already learned two procedures for doing the same thing. Now, we've got the same problem, apples, and some of them being rotten. The probability of an apple being rotten is 0.35. And our first question says, what's the probability that exactly 20 apples are rotten? Okay, so what does this mean? This is the probability of x equals 20. So we know, like if we were going to use our formula from before, one way we could write that is 50c20 times 0.35 to the power of 20 times 0.65 to the power of 30. Okay, 20 rotten, 30 not rotten, that's going to be the calculation. Or we can follow this procedure. We're going to go menu, statistic, distribution, binomial, Bcd. All right, and this is the information that we're going to put in there. The number of successes, the number of trials, and the probability of success. So if you go to Bcd for me, guys, thank you. Good. We're going to go x is 20. We're talking about 20 successes out of 50 with the probability of a success of 0.35. All right, and that's going to be the fastest way for us to evaluate that problem. Okay, so that's going to be 20, 50.35. And so the probability of exactly 20 apples being rotten is 0.08750. Okay, so 0.0875. Okay, part B. How about more than 20 apples being rotten? So when you think about how many apples could be rotten out of 50, right? There's sort of like, okay, you could have 18 apples rotten, you could have 19 apples rotten, you could have 20 apples rotten. This is the event we calculated, didn't we? We said, what's the probability of exactly 20 being rotten? And it's just under 10%, okay? 0.0875. Now we're asked, what's the probability that more than 20 are rotten? Okay, if it's more than 20, that means it's everything above 20. All right, so that means from 21 all the way up to how many apples there are. All right, so because we're not calculating an exact outcome here, we're calculating a number of outcomes. We're saying, what's the probability of it being 21 apples being rotten, plus the probability of 22 apples being rotten, plus the probability of 23 apples being rotten. We're saying, what's the probability that more than 20? So it could be any of those events, any of them. So we're saying all of them added together. So this is a Bcd calculation. We're talking about the probability of x being larger than 20. Okay? Has to be larger than 20. So the next whole number, another way we can express this, is the probability of x being larger than or equal to 21. Okay, but it has to be larger than 20. The next value that it can take, these are discrete values, has to be whole integer values, is 21. This is a Bcd calculation, all right? Because it's a cumulative sum of individual events. The lower boundary is the lowest possible event we're talking about. What's the lowest amount of apples that could be rotten? 21. What's the upper boundary? That's the highest amount of apples that could be rotten. We're talking about 50, because we've got 50 apples in the crate. The number of trials is 50, and the probability of it being rotten is 0.35. So that's going to be 20. Okay, can someone do this? Because I've got the old software. I've got 0.1860. Just someone check for me. Correct? Excellent. Okay. So what that means is there's an 18.6% chance, or a probability of 0.186 of more than 20 apples being rotten, or 21 or more. Okay, so you've got to think about that language. Okay, so there's our answer to part A. Here's our answer to part B. We're on to part C. Part C says, what's the probability of less than 20? Less than 20. Okay, so if you think how many could be rotten, we're saying less than 20. It has to be under 20 that are rotten. So that could be 19, could be 18, could be 17 rotten. It's all of those events. All right, so again, it's a BCD calculation. We're talking about the probability of X being less than 20, not including 20, less than 20. So another way that could be represented, less than or equal to 19. The next possible value it can take is 19. So then we're doing our BCD calculation, okay, because it's cumulative. We're talking about the sum of those events added together. Lower, upper, number of trials, and probability. So, our lower boundary, all right? Our lower boundary is the lowest possible value this could take, okay? So when we talk about them going rotten, how far down here does it go? It goes all the way to 0, because you could have this crate of apples, this ideal crate of apples where none of them are rotten. So our lower boundary is 0. We're saying it could be 0 that are rotten, and our upper boundary is 19. All right, that's as far as we're going along the scale. There are 50 apples in the crate, and the probability of it being rotten is 0.35. All right, so we'll do this calculation. We've got 19. All right, and I've got 0.7264. 0.726. Okay, I'll just talk about how they've calculated this event, okay, the probability of X being less than or equal to 19, all right, so what the calculator's done for it, so we've got a 72% chance, right, or 73% chance, so it's very likely that less than 19 apples are rotten, so it could be 19 apples are rotten, it could be 18. The way the calculator has done this for us is they've said, what's the probability that 19 are rotten, plus the probability that 18 are rotten, plus the probability that 17 are rotten, and it's added all of them together. All right. You think over here we did it for 1. We did it for when X is 20. It's doing it for all of those individual events and then adding them together for us. So you could do it individually. It just take a very, very long time. All right. So we evaluated that. We've done. So then on to part D. Between 20 and 30 apples are rotten. Okay, so we need to be careful with how language is used here. It is a little bit ambiguous, so I imagine there's a bit of leeway. So let's look at two possible cases. 20 to 30. Sometimes it'll say inclusive. Okay, so that means including 20 and 30. And sometimes it will say not including. All right, so that's the sort of language we've got to look out for. Let's say, for the sake of argument, that we are not including, okay, that we're not including 20 and 30. So it's saying between 20 and 30, all right, so we've got 20, 21, 22, 23, all the way up to 29, 30. So between 20 and 30, but not including 30, all of those events, all right? So your calculator, I mean, you could work out the probability that 21 are rotten, plus the probability that 22 are rotten. But for our calculator, this is going to be a BCD calculation. Our lower boundary is 21. Our upper boundary is 29. We've got 50 trials, 50 apples in the crate, and the probability of being rotten is 0.35. Yeah, can someone match that for me? Thank you. So we've got, 18.6% chance of between 21 inclusive and 29 apples being rotten, or between 20 and 30 not inclusive of those boundaries. Okay, part E. What is the significance of the sum of your results to part A, part B, and part C? So if you went part A, that, plus part B, that, plus part C. Who wants to have a guess what we're going to get? 1. Why? Because the sum of all events is 1. What are we doing there? We're calculating the probability of x being less than 20 plus the probability of x being 20 plus the probability of x being larger than 20. All right? And that is every possible event. So the sum of the probabilities will be 1 because it includes every possible event that can occur. There could be less than 20 apples, there could be 20 apples, or there could be more than 20 apples. Excellent. All right, so let's get into BCD. This is a very fun topic, so yeah, let's do it.